Alright, in the last lecture we have compared recursion versus iteration, and we saw that in many cases iteration performs better than recursion in terms of time and space complexity. But there are situations where recursion is preferable instead of iteration. Now here, let's examine the situations when we should use recursion and when we avoid it. So as we discussed in our previous lecture, the recursion is always used if you can easily break down problem into a smaller subproblems. In these kind of cases, we should always use recursion. Now the next point is that we should be aware of that whenever we use recursion, it brings with itself extra overhead. As a programmer, we might not be aware of it, but the system manages it internally. So there might be time problems as well as space problems. So if you think that the system will handle it without any problem, then go for recursion. This means that recursion method that you are developing will be run on supercomputers. But there might be situations where you cannot compromise either with space or time. Then in those cases, we need to avoid recursion. For example, if you are developing a mobile application, which should run on low memory devices as well, in this case, recursion is not advisable. Similarly, if you are developing an algorithm for critical system, which must be so fast, like the airbag system in the car, where a fraction of seconds matter, you must avoid using recursion in these kinds of application. The point here is that there might be situations when we need a quick solution. Instead of thinking efficiency of algorithm, we develop solution using recursion. As we saw in our previous lecture, writing code using recursion is much easier. For instance, solving mathematical problems like factorial or Fibonacci, we can use recursion as an easy solution. In the upcoming lectures, we will see how to implement recursive method for Fibonacci and factorial numbers. So the recursion adds clarity and reduces the time needed to write code and debug code. If your input into a function is going to be small, then recursion is certainly a good choice if you want to declutter your code. If your input is sufficiently large, however, the sacrifice of speed and memory for the sake of clarity becomes much less attractive and functional. Now the next point is recursion is very useful when we traverse a tree. Recursion is better at tree traversal. This is a little bit a more advanced topic, so we will explain it in our tree section, but an extremely simplified version of what this means is as follows. A tree is a collection of objects that are linked to one another. So imagine leaves on a tree connected by branch and that are in turn connected to other branch of all the way to the roots. So this is the root and these are the other branch of the tree. One of the more efficient ways to traverse this tree when we are looking for a specific leaf, or in tree terms it's a node, by recursively following a single branch until the end of that branch and find the value that we are looking for. There are different types of traversal of tree, which we will discuss in tree section, but here you just need to know that recursion is very beneficial when we use pre-order traversal. When we recursively following a single branch until the end of that branch and find the value for looking for. For simplicity, in case of this tree, the pre-order traversal will be like this. So as you can see, we are starting from loop and visiting all nodes of the left branch, and then we are coming to nodes of the right branch. So as you can see, from after 15 comes 9, 3, then 1, 4, 12, and it continues like this. So you don't need to worry about this. We will look at this one in our tree section. Finally, when we use memorization inside recursion, the time complexity can be reduced. This means that, so if you memorize the result by saving the value of each calculation for future use in the recursive call, you can in fact reduce the time complexity. So this is also an advanced topic, so I don't want to waste our time and confuse you over here. So this topic also will be explained in the dynamic programming section. Now let's continue to see in which situation we cannot use recursion. So here we can easily see that when we face the reverse case of these 3 points over here, we cannot use recursion. So if we cannot divide problem into the similar subproblems, this means that recursion cannot be. So recursion use more memory because the function has to add the stack with each recursive call and keep the values there until the call is finished. The memory allocation is greater than an iterative function. So if we use embedded memory, for example, an application that takes more memory in the phone is not efficient. So in terms of time and space complexity, recursion is not efficient. So as we mentioned, recursion is not space and time efficient. So that's why if the time and space complexity matters, we need to avoid recursion. Now the second point is recursion uses more memory. Because the function has to add to the stack with each recursive call and keep values there until the call is finished, the memory allocation is greater than that of an iterative function. So if we use embedded memory, for example, an application that takes more memory in the phone is not efficient. So you also notice that if you see an application that takes more memory in your phone, everyone deletes that application from their phones. So especially mobile applications have to be memory efficient. Now the next point is recursion can be slow. If not implemented correctly, it can be much slower than iteration. It's actually pretty difficult to write recursive function where the speed and the memory will be less than that of iterative function, completing the same task. The reason that recursion is slow is that it requires the allocation of new stack frame. So as we discussed in our previous lecture, whenever a function calls itself recursively, it adds it to the stack memory. So this takes space in the memory, so this is not memory efficient. And when we are popping and pushing that functions from the stack, it takes time, so this is not time efficient. So with this, we have completed this lecture. So in this lecture, I have explained in which cases we can use recursion and in which cases we can avoid it. So hopefully you have understood it very clearly. So see you in the next lecture.